We will continue now with the talk by Mary-Jane BOPAPE. And as soon as we have fixed our technicalities within our venue, because we couldn't hear the sound, we will go back to the talk by Professor SCAIFE. Mary-Jane, please.
Okay, thank you very much, Francesco. Yeah, and good afternoon, everyone. I was happy to get invited to come and speak here. And this is also considering my career. So the organizations, pretty much, I've got a history with the organizations that are organizing this school. My first trip outside of South Africa was to ICTP, and I did my master's using their model called the REDCM3. So I have worked with the ICTP. I've been there. I think I went to Trieste 3 times, working with Filippo Giorgi. And then with NITheCS, I am a member of the advisory board, and CHPC is basically my former employer, and I continue to work with them really closely. And yeah, so we continue to collaborate, and I'm also one of the big users of their machine. So I'll be sharing with you work that we are doing in South Africa. So this, as you can guess, will be like selected activities that are taking place in South Africa around the observation networks, as well as around numerical weather, as well as climate modeling. I am with the South African Environmental Observation Network. And as you can see there, that 21st anniversary is basically to say we are celebrating our 21st this year. So I'm hoping Imraan will declare us as a national facility. Yeah, so SION is a business unit of the National Research Foundation. NRF gives postgraduate funding, and we also have national facilities that conduct research. We were founded in 2002, and most of our funding are from the Department of Science and Innovation. So we are really there to assist with the use of science, technology, and innovation to solve environmental challenges. So our vision is to provide world-class environmental research platforms for a sustainable society. Now, one may ask why environmental sciences, or why the earth sciences, and what I'm showing you here are results, or what came up from the global risk reports in the last 3 years. So these are considered different areas. So you can have economic challenges, you can have environmental risks, geopolitical risks, societal risks, as well as technological risks. And the ones that you see that are in green there, those are the environmental risks. So what they do is they conduct surveys, and they interview experts, and they ask them what do they perceive as global risks in the next 10 years. And you can see green is just coming up. So these are ranked based on likelihood as well as on impact. And you can see that these environmental challenges are really coming up. You can see biodiversity loss, you see extreme weather, natural resource crisis, human environmental damage. And if you look at the 2022 report, you can see the top 3 were all environmental risks that were coming up. And then the latest report, which was published in 2023, they considered what would be the global risks in the next 2 years and what would be the global risks in the next 10 years. And again, I don't have to list there, but what's coming up is there's a whole lot of green that's coming up there. So the environment, it's really, if we have environmental challenges, we can have a lot of disasters. And now this speaks to what we are really observing. So there is CRED Center for Research on the Epidemiology of Disasters, CRED, which is recording disasters that are taking place, that are being recorded globally. And what we are looking at here are the disasters that were reported in the whole African continent, going from 1979 up until the end of last year. And you can see that the majority of these natural disasters are hydrometeorological in nature. You see floods there, you see droughts, you see storms, You see insects, and then you also have landslides there that are coming up. So the hydrometeorology is really coming up. And we also see the same thing with South Africa. You can see floods are leading in terms of the disasters that are being recorded, natural disasters, followed by storms, followed by droughts. I know some people say MDAT underestimates, and we know it's because they are strict, with regard to the number, with regard to the events that make it onto their list. But just looking at what's recorded, you can see that the hydrometeorological issues are really coming up. Then for South Africa, what we've done was actually to also check where are we recording the most disasters. And this is results that you can interact with on the South African Risk and Vulnerability Atlas. So this is a project that is funded by the Department of Science and Innovation. So on our server platform, you will see which parts of South Africa are reporting which disasters. So when you click on the atlas, you can click a district. South Africa has 52 districts and metros, so 44 districts and then eight metros. So we've mapped which are reporting the most, and this is results looking at data. So on the atlas, you'll find data going from 1952 up until this year. So how do we deal with some of these disasters? And it is, I mean, there are different ways that you can deal with this, but one of the ways to do this is the use of early warning systems. So, with property damage, if there's a house that's damaged, there's very little you can do if the house has already been built. But then when you look at loss of life or loss of movable property, that is something that early warning systems can assist us with doing. So early warnings can reduce the severity of disasters as they are occurring. And this is something that keeps coming up. The World Meteorological Organization publishes state of climate reports. They started publishing from 2020. They published the 2019 report. And with all these reports that keep coming up, they keep stressing the importance of early warning systems. Last year, during World Meteorological Day, the UN announced that by the year 2027, they want the whole globe to have access to early warnings. So you can see this is something that is really acknowledged. For South Africa, our very own National Development Plan mentions that South Africa needs to develop modeling capacity to assist with climate change adaptation. So this is a statement that you'll find in Chapter 5 of the National Development Plan. Now, what are the components of early warnings? So we have observations. So you need to know the state of the environment to be able to predict it. We have models. So the so-called numerical models are what we use to have a lead time of anything beyond 2 hours. You can kind of extrapolate forward from, let's say, radar data of some satellite information, but that information is only, if you extrapolate that way, is only reliable up to about 2 hours. Beyond 2 hours, you have to use numerical models, and they solve partial differential equations like the ones that you see written down there. And obviously, you need to have post-processing where you combine the observations as well as the models, perhaps to do the bias corrections. Then scientists can then use that information to answer some research questions. Forecasters can use that information to issue warnings. And there are products, you already had the example of energy, that climate impacts or weather impacts on energy. So you can develop products for climate sensitive sectors, such as agriculture, health, water, as well as for disaster risk reduction. And obviously then there's the point of dissemination, which is actually very important, because you can produce the best or a perfect forecast. If the people that need to react to it do not receive it, then it becomes a useless forecast. But in my presentation today, I'll just talk on the observations as well as on the models on what we are doing here in South Africa. So this one is just to show you the type of challenges that we are dealing with on the continent. So where you see colors, that is where we've got observations. And what we know is that the African continent does not have enough ground observations. I was just reading the climate change strategy for Africa, and it says that we don't even have 1/8 of what is needed to be able to cover, what's needed. Let us say, this is the basic observation you need to be able to predict properly. And for us here in South Africa, we're also in the Southern Hemisphere. So you can see that it's actually the hemisphere actually as a whole has very sparse observations. And what does that lead to? What I'm showing you now in this slide, these are satellite products. So that very first one there, so this is from a project that I'll speak to, a SADC project that I'll speak to later. But when you look, so that first part, that's Botswana, you can see. So we've got ground observations. That's where you see the dots. So that is where there were in situ observations that we're collecting. And then you have IMEC. So this is a NASA rainfall product. So quantitative precipitation estimate. And then below it is a rainfall product from University of Reading, TAMSAT. And then next to it, you've got ERA5. So ERA5 are the reanalysis that the meteorologists really trust. They really use this reanalysis to understand processes. So all those are supposed to show one thing. So it's rainfall on a specific day, 18 February 2017. And all of them are considered observations. And so you can see the challenge that's there. So it's a specific day and you are asking the question, did it rain or did it not? And you can pick a spot. Some areas, one observation product says there was no rainfall at all. Another product says there was a lot of rainfall. Another one says there was little rainfall. So, and that is a problem that occurs because we don't have enough ground observations. And so here it's really the same thing, but this one is IMEC, the NASA one, as well as University of Reading. Again, the same days. Now, in this case, this is an example for Zambia. So it's not something that is restricted to a specific country, but we see it across the African continent. Now, this is one of the interventions that came through when the SION, the organization I work for now, was established in 2002. And the point was that we need to understand the Earth system really well. And that is where the observations come in. So where you see dots, that is where we have landscapes. And that is where we are taking observations. So you see big gaps, yes, but then what you are noticing is that everywhere where you have a different color, there is a dot that is available. So those are the different biomes, different vegetation types. And what we do in these landscapes is that we put up observations. We don't put up just one, but what we do is within the landscapes, we put up dense observation networks so that we can understand what is happening with high resolution. And as we get to understand these processes, the information can then inform the development of models. The information can then be used to calibrate satellite products. So this one here is an example of one of the landscapes. This is Cathedral Peak, so it is in the northern Drakensberg. And you can see that within that landscape, we have 33 rainfall stations. We've got 3 AWSs. We are planning to add more automatic weather stations. We've got one eddy covariance system. We are planning to add more. We are also taking observations, for example, looking at the impact of different vegetation types on water security. We are looking at the impact of different vegetation types on the amount of available carbon dioxide in the soil. One of the interesting results that's coming up from our studies is actually that a forest is not good for water security and a forest is not good for carbon. So we find that the grasslands are keeping more carbon in the soil, while once you start planting more trees, you are actually getting that carbon out of the soil. And I mean, it's a question of how long are you going to keep those trees there for? So it's an interesting one that says now people shouldn't just come and plant a lot of trees without asking what is the proper biome of the environment. If you see a grassland, it doesn't mean it's degraded land. It could actually be that is its natural state. And these landscapes that we have in the Drakensberg, for example, help us to understand those types of questions. We are also working on, we are implementing 3 projects of the South African Research Infrastructure Roadmap. So the SARIR program is being implemented by the Department of Science and Innovation. There are 13 research infrastructures that have been identified, and 5 of them are within the environmental sector. And SION hosts 3 of these research infrastructures, and I'll speak just a little bit to these. So the first one is called FTON, the Expanded Freshwater and Terrestrial Environmental Observation Network. And we have identified 6 landscapes where we are going to be putting up a lot of observations. So you can see the different platforms that we would like to put up, including how we engage with the environment ourselves. I mean, we want to have scientists going out there, counting the number of trees so that we'll be able to calibrate information that is coming out. The biodiversity, the atmospheric science, the hydrology, we're interested in water quality, we are interested in the water amount. And all this information is needed to inform the model development. So there are 6 landscapes, as I've mentioned again. When you look at the different colors, you can see that we have selected different biomes that would like to be able to understand how they are changing and also to understand the variability. Then the next one we have is called SMECRI. It's Shallow Marine and Coastal Research Infrastructure. And with this one, we want to be able to take observations across the whole coastal line of South Africa, including the shallow waters adjacent to us. So we've got a number of different platforms that we use. We've got a labs where once we've taken samples from the oceans, we are able to analyze from that lab. We've got an aircraft following the floods in KZN. We actually went and surveyed that aircraft, to look at the impact of those KZN floods. We've got a hyperbaric chamber, with which we have partnered with the private sector. So to have divers, we have divers that need to go into the ocean to collect samples. And for the hyperbaric chamber, it needs to be close by in case there's an accident, to assist the divers. And we are in a PPP agreement with the private sector. So we've got a medical doctor who's using that chamber actually to assist the community in Gqeberha. Then we also host the South African Polar Research Infrastructure. So the first 2 that I mentioned, we started hosting them since 2016, 2017 when they were launched. And okay, thanks. Hopefully I'll stop coughing. Yeah, so as I was mentioning, so FTN and SMECRI, we've been hosting them since 2016, 2017. Then since November of 2021, we are now also hosting the South African Polar Research Infrastructure. So it also involves long-term observations over land, long-term observation in the ocean. So over land, we are referring to Antarctica and the oceans, your Marion Islands and your Gulf Islands. And then in the oceans, we are actually now not talking about the shallow waters, but the deep in the waters where we take observations. So we're interested in the biodiversity, we're interested in the dynamics of the ocean, we're interested in the physics. And we also have a polar lab that's being built at the University of Cape Town. And with that lab, we actually want to replicate the conditions of Antarctica. So the hope is that, you don't need to be in Antarctica to experience what it's like to be in Antarctica. You can just go to UCT and see what it's like. So what this means is that when you combine the SION observations, you combine the 3 research infrastructures that I've just mentioned. In terms of observations that we are taking, you can see we cover from the northern parts of South Africa. Therefore, we go all the way to Antarctica. Obviously, like I say, it's not that you cover everything, but there are selected areas where you get to understand processes really well. And this information is really crucial to inform models. Then I already mentioned that an important component of early warning system is modeling. And we are also interested in the running of models. And for us to be able to run these models, we need high performance computing facilities. We run both global models, we run regional models. We do dynamical downscaling, either using the traditional way of nesting or using variable resolution. And we are also interested in like the use of large AD simulations. And the figure there just shows you that, when you model the Earth system, there are different components that you need to model, and it just says all these processes need to be represented somehow in the models. So this one here just shows you there are a number of models that we've been running in South Africa, different models that we've compared, a number of sensitivity studies, there's operational modeling that's taking place, there's pilot climate studies that are taking place, and all of these have actually been made possible by the CHPC. So big advancements in South Africa around modeling happened because of the availability of the high performance computer. We also run ocean models. So this is a program that we are running at SION. It's called Shumishana. It's around ocean modeling. So there are ocean models that are running in South Africa, in particular ROMS, which was developed in France. And then there's another model, NEMO, that I know the CSIR is also using. And we've got a project that is funded by the Department of Forestry, Fisheries and Environment to run these ocean models to produce forecasts that can then be used by the public. We know that models have shortcomings. The example I'm showing, you can just focus on the one on the right. So what you see in blue, those are the observations. And I want you to look at the middle plot. It shows you for the two that are in the middle, you can see there was an observed maximum. And the ones that are below are just different configurations of the same model, which is called the CCAM model. And what's really coming up is that when we've got the most extreme of events where there's a whole lot of rainfall that is observed, the models don't pick this. And now the question is that if you just download a model, compile it and run it, and you don't know how it's developed, how do you improve things such as this? So it comes back to the opening that said that we need to develop our own models. So there are activities in South Africa around the development of models. In fact, these activities were revived in 2002, but it's more than 20 years now that these have started, but we still don't have a critical mass that can be able to develop these models. There are a number of projects that are running, funded by the NRF, funded by AIMS, as well as the Water Research Commission, that are trying to assist with this. But we really need more people that will contribute towards this development, because we are not moving as quickly as we would like. So the other thing I want to mention is that the data set, I mentioned all the landscapes and then the models that would like to run, all our data is open. So if you want to come use our data to assist with model development, you can just go onto our catalog and download that data set for your use. And we've also contributed to a project, a SADC project. So we are assisting with the implementation of the SADC Cyber Infrastructure Framework. So we got funding from the DSI, and we also got funding from UNECA to run this project, where we engaged with a number of countries, 6 countries, where we did some sensitivity studies. And this is just an example from Zambia, where we were looking at how different simulations are when you use different planetary boundary layer schemes. So the models have different components, and there are sensitivity studies that you can do with them, and the performance differs, but the point is we need to start developing our own. We also do some programming training. So since the project started, I think since around 2018, we've been running training programs. And last year we ran one where we partnered with a number of organizations. You can see the different logos there of the funders as well, organizations that partnered to do this training, where we gave training on high performance computing, numerical weather prediction, QGIS, so different areas. And there were a number of organizations, different countries that were represented there. So I'll conclude. I don't know how I did with time. But I think so the main message is really that the environmental sciences or the earth sciences are crucial. So if you wanted to do work that you can link very easily to societal benefits, the environmental sciences should be at the top of your list. And we need observations. There are different ways that one can contribute. So we need observations, we need sensors, which is another area which I didn't speak to, the fact that all our sensors are coming, most of our sensors are coming from the US, which means they are getting more and more expensive with time because of the exchange rate. So we need technicians to work on those sensors. We need engineers to develop sensors. We need scientists to analyze the data. In terms of our models, we need people with a background in maths, to understand, who can understand the numerical techniques, so that we can develop these models better, so they can run faster. People with the data science background who can use machine learning techniques to develop parameterization schemes. So there are funding opportunities within SION. We've got a graduate student network that allows postgraduate students to engage. So I think just in conclusion is to say the skills that you'll be learning this week are really crucial, and I think they can be used within the environmental sciences.
Very much, Mary Jane.